Hello viewers, in my previous lecture I have introduced you to fatty acids and we have also discussed the classification of saturated acids. In this lecture we shall be discussing the classification of unsaturated fatty acids. As I have told you previously, on the basis of the nature of carbon chain, fatty acids can be divided into two categories, that is saturated fatty acids and unsaturated fatty acids. In saturated fatty acids, hydrocarbon chain is saturated, that is there are no double bonds in that chain, double or triple bonds in that chain, and all the carbons of the hydrocarbon chain are saturated by hydrogens. Whereas when we talk of unsaturated fatty acids, we find that these fatty acids have one or more points of unsaturation. So when we say unsaturation, what we mean is that 1 or 2 points hydrogen will not be there, and there will be double bond between carbon atoms. That is, all the carbon atoms will not be linked to hydrogens. So such fatty acids will be are known as unsaturated fatty acids. Now, unsaturated fatty acids are found in foods from both plant and animal sources. So as you can see on your screens, that is, unsaturated fatty acids can be further divided into monounsaturated fatty acids and polyunsaturated fatty acids. Here I have taken an example of a monounsaturated fatty acid, which you can see on your screens. And what we find that in monounsaturated fatty acid, which I have taken oleic acid as an example, what we find here, that is, we have a point of unsaturation here. That is, these carbons are not saturated by hydrogens. Instead of that, there is a double bond between these two carbons, and there is only one double bond, so therefore we call them as monounsaturated fatty acids. So on the basis of the number of double bonds in a fatty acid, they can be classified into monounsaturated fatty acids, which are known as MUFA, or polyunsaturated fatty acids, which are known as PUFA or eicosanoids. So when we talk of monounsaturated fatty acid, that is MUFA, or they are also referred to as monoenoic acids, they contain one double bond, as I have just illustrated, and the general formula of this monounsaturated fatty acids is CnH2n-1 COOH. If you recapitulate the general formula for saturated fatty acids, it's CnH2n COOH. Since there is no point of unsaturation in them, the general formula is CnH2n COH. But in monounsaturated fatty acid, there is 1 degree of unsaturation. Therefore, the general formula becomes CnH2n- COOH. For example, if I take an acid having 3 carbon atoms in it, so H will become 6 minus 1. That is C3H5COOH would be the acid, will be the monounsaturated fatty acid. And for this, I have taken an example again of palmitoleic acid. And what we find that in palmitoleic acid, now I would discuss all of this in detail later on in the lecture on nomenclature, but let me just tell you quickly, what does 16 indicate here? 16 indicates that this acid has 16 carbon atoms in it. 1 indicates that there is 1 double bond in this acid. and 7 indicates that when we start numbering from here, 1, 2, 3, 4, 5, 6, okay, we start numbering from this side, 1, 2, 3, 4, 5, 6, 7, we have a double bond at the 7th position. See, this was slightly confusing. I'll just take 1 minute here. That is, when we are, in this case, we are numbering it from methyl side. So when we are numbering it from methyl side, the methyl group will get number 1, 2, 3, 4, 5, 6 and 7. We are having double bond at the 7th position. So this is what has been indicated here. So when we are numbering it from methyl chain, and if you remember, I told you in my last lecture that this is known as the omega end or the methyl end. So we can say this is omega 7 carboxylic acid, fatty acid. So this is palmitoleic acid. And now if you look into the formula, molecular formula of this acid, is what does it indicate? CN H2N minus 1. So it fits into the general formula for the series of unsaturated fatty acids. That is, here it is 2N minus 1. So you don't have to remember the formulas as such, the molecular formulas. If you know the number of carbon atoms, from that you can derive what would be the molecular formula of that particular fatty acid. So from here now we can say palmitoleic acid is a monounsaturated fatty acid which has 16 carbon atoms in it. It has 1 double bond, and the number of the double bond occurs at 7th position when we start numbering from the omega end of the fatty acid. Now, what is the importance of palmitoleic acid? Palmitoleic acid is present in adipose tissue and breast milk and liver of humans. Plants and marine oils are good sources of palmitoleic acid. This palmitoleic acid is anti-inflammatory and improves insulin sensitivity in liver and skeletal muscles. Now the next acid which is very important is the oleic acid. This oleic acid is also known as omega 9 acid. Now what you find when you look into the structure of oleic acid, we have 17 carbons in it. So immediately you should know that the hydrogens will be 33. That is 17 into 2 minus 1. Plus we have a carboxylic group here. Now what does this 18, 1 and 9 indicates? 18 indicates that oleic acid has 18 carbons in it. It has 1 double bond, and this double bond is at position 9 from the methyl end. When I am saying it is omega 9, 1, 2, 3, 4, 5, 6, 7, 8 and 9. The double bond is at position number 9. And what you have to remember is oleic acid is an essential fatty acid. I'll be dealing today in the lecture itself like what are essential and what are non-essential fatty acids. And please remember, oleic acid is the most common fatty acid in nature. It is present in abundance in sesame seeds, sunflower and olive oils. Olive oils contain 84% of unsaturated fatty acid and 16% of saturated fatty acid. That means olive oil, which is a Mediterranean oil, is considered quite good source of fat. But please remember, we are switching to olive oils now. But olive oils, I think, are more suitable for Mediterranean countries or for European countries. We are happy with the mustard oil and the vegetable oil, that is the coconut oil, soybean oil, which we are using here. Olive oil is generally used for dressings. It is not good for frying. So now what are the advantages of oleic acid? Oleic acid, please remember, is present in olive oils and other sources, and the importance is it improves insulin sensitivity, it improves immune system, it lowers blood pressure and is essential for brain function. So this is the importance of oleic acid, and please remember it is omega-9 acid. Now we go on to nervonic acid. Nervonic acid is an unsaturated acid and it is tetracose. So when I say tetracose, that means it has 24 carbon atoms in it. And if you remember, in my last lecture we had done tetracosanoic acid. There it was, when we said ane, that was a saturated acid, and now we are saying it is ene. It is a unsaturated acid. And in this case, we have done the numbering from the carboxylic end, and this double bond is present at the 15th position. This is also called as shark oil. Why is this called as nervonic acid is called as shark oil? Because it is present in fishes and it is an unsaturated acid. So the two acids which I have discussed here, unsaturated acid, and which I consider are important, one is oleic acid, the other I have discussed is nervonic acid. Oleic acid is present is a omega-9 acid. It is an essential acid, fatty acid. Whereas when we talk of nervonic acid, please remember, is present in cerebrocytes. It is important from this biological point of view, and it is the acid which is present in cerebrocyte neuron. So I've just discussed few examples of monounsaturated fatty acids with you. There are more monounsaturated fatty acids with you are available, but due to shortage of time we are not able to discuss all, but I have discussed the three important ones. Now we go on to double bonds in unsaturated fatty acids. So when we have double bonds in unsaturated fatty acids, and when we are talking of these double bonds itself, before I go on to more of polyunsaturated fatty acids, now I would like to discuss with you what can be the structural orientation of the double bonds, which is very, very important. So if these double bonds in unsaturated fatty acids can have two structural orientations, one is cis and the other is trans. So now we are discussing MUFA, that is monounsaturated fatty acids. And what we find when we have two orientations, one is cis and the other one is trans orientation. When we are talking of the cis orientation, what we find that the hydrogens are on the same side of the double bond, provided that the groups attached to the double bonds are different. You are familiar with cis-trans geometrical isomerism. We say a alkene is having a cis configuration if the two identical groups are on the same side of the double bond, and it is having a trans configuration when the two similar groups are on the opposite side of the double bond. So when we are talking of cis orientation in these monocarboxylic fatty acids, what we find that the two pieces of carbon chain on either side of the double bond are on the same side. That is, they can either be above the plane or they can be below the plane. That is, they are on the same side of the double bond. And when we talk of trans orientation, what we find, the hydrogens on the carbons involved in double bond are on the opposite side of the double bond. They are opposite to one another, that is, they are anti to one another. So what we find that when we look into the structure, as you all can see on your screens, so first here I have just indicated what do we mean by a cis and a trans. So when you have a cis orientation, what you find that the two hydrogens are on the same side. So this you can remember from sisters. Sisters are always on the same side. So this is the syn configuration or the cis configuration. And trans, you are on the opposite side, enemies. So in trans configuration, the hydrogens are on the opposite side of the carbons containing the double bond. And now if we look into the shape of these two structures, which will really affect the physical properties of these acids, the melting point, and how they are easily digestible or not. What we find that cis has a kink in it, that is, the structure will be bent here, whereas in trans the two hydrogens are on the opposite side, so they adjust easily, and this has a linear structure, more linear structure as compared to the cis form. So what you find now, if you look into in reference to the unsaturated monocarboxylic acids, what we find that in trans they are opposite to each other, and they're accommodating, these hydrogens are accommodating very well, and the molecule has linear structure here. Whereas when we talk of cis, we have to adjust the hydrogens on the same side. So what do you find that here it is bent? We have a kink here, and this will greatly affect the properties of these fatty acids. So when we talk of cis fatty acids, what we find that cis fatty acids are important as they are found in naturally occurring fats and oils. Cis fatty acids are abundant in salmon, walnuts, corn oil, sunflower oil, and flax oil. They decrease total cholesterol and triglyceride levels, and they increase the good cholesterol, that is HDL levels. Whereas trans fatty acids, on the other hand, are formed mainly during hydrogenation of liquid vegetable oils, that is during the manufacture of margarine. Now see, the cis which are useful to us, which are beneficial to us, are existing naturally in fruits, vegetables, fats, natural animal fats, whereas trans ones are the ones which we are synthesizing in the laboratory by hydrogenation of liquid vegetable oils. And they are present in, where are they present now? The trans gives little extra flavor, so they are present in commercial baked foods as cakes and cookies, frozen pizzas, and most fried foods. Trans fats may act similarly to saturated fats and contribute to heart disease and even some cancers. In fact, when we will be discussing trans fats with you, we know that sometimes trans fats are even more dangerous than saturated fats, because we have in our mind that they are unsaturated fats and we consume them more and we avoid saturated foods, whereas what we find that trans fats are more dangerous than saturated fatty acids. Now these trans fatty acids, what is the harmful effect? Why should we avoid oils or fats containing trans fatty acids? Because they raise levels of low density lipoproteins, that is LDL, bad cholesterol, and triglycerides in blood. They also reduce levels of high density lipoproteins, that is HDL, which is the good cholesterol. And what we find as a result of it, the ratio of total cholesterol to HDL cholesterol is raised, which is harmful. And all of these parameters put an individual at high risk of cardiovascular failure or heart attack. So these are the drawbacks when we consume trans fats. Now these trans fats may be monounsaturated or they can also be polyunsaturated fatty acids. So till now I have discussed with you few examples of unsaturated, monounsaturated fatty acids and the difference between the cis fatty acids and trans fatty acids, the disadvantages of trans fatty acids. Now let us discuss what are polyunsaturated fatty acids. They are abbreviated as PUFA. PUFA for poly, unsaturated, U for unsaturated, F for A for fatty acids. And as the word indicates poly, these fatty acids will contain two or more double bonds. And now as you can see on your screens, depending on the position of the double bonds, the three categories of PUFA are conjugated double bonds. Now, what do we mean by saying conjugated double bonds? That is, in this molecule, you have an alternate double, single, double bond. So, this is one arrangement which can be present in PUFA, and for this, the example is conjugated linolenic acid, that is CLA. That is, in conjugated CLA, what do we find? We have conjugated double bonds in it. This is the alpha end or the carboxylic acid end, and this is the omega end or the methyl end. This end is water soluble, this is not oil soluble, and this end is water soluble, and therefore we say that fatty acids have amphiphatic in nature. Now we go on to unconjugated. Now what do we mean by saying unconjugated? That is, there is no conjugation, there is no alternate double and single bond. When we talk of an unconjugated double bond, we mean that the double bonds are separated by carbon atoms bonded with single bonds, usually in a methylene interrupted arrangement. So what you find? You have a double bond here, then you have a single bond, then again you have a single bond, and then we have a double bond. So what you have to remember here is, when we are talking of an unconjugated system, that is, there should be at least two or more than two single bonds between the carbons which are containing the double bonds. If this is the arrangement, we will say the arrangement is methylene interrupted arrangement. Now we go on to a third category, or let us see the example. And what we find here is that we have, in this case, we have alpha linolenic acid. When we talk of alpha linolenic acid, here what we find is, we have a isolated arrangement in them. And what you'll find that in nature, mostly the fatty acids have isolated methylene arrangement in them. The third category exists in which double bonds are not all entirely in the methylene interrupted arrangement, and these type of category or these type of acids are present in certain microbes, marine lipids, and some seed oils. Now when we talk of unsaturated fatty acids, we have to discuss two very important families, that is omega-3 and omega-6 polyunsaturated fatty acids. These are unconjugated polyunsaturated fatty acids which are common. So when we are talking of omega-6 or omega-9 or omega-3, what do we mean by that? We mean that the double bond is at the third position, sixth position, or ninth position, starting from the omega end. So depending on the position of the double bond, closest to methyl side chain, which is numbered 1 on the fatty acid chain, we have 12 omega acids are known. And among these 12 omega fatty acids, the important ones are 3, 6, 9, and which we have to consume in our normal diet also. On your screens now you can see the slide is not very clear, but this is just for an illustration that we can have different categories. That is, this will depend upon the number at which the double bond is present from the methyl end. So we can have omega-3, we can have omega-5, we can have omega-6, we can have omega-7, we can have omega-9, and so on. So this omega numbering is been given on the basis of the position of the double bond starting from the methyl end or the omega end. So now let us discuss what is omega-3. Omega-3 are fatty acids which are also referred by W3, that is omega-3 acids, or N-3 fatty acids with a double bond at the third carbon atom from the methyl end of the carbon chain. So this is what you have to remember, that the double bond will be at the third position when we start the numbering from the methyl end. And there are three types of omega-3 fatty acids which are involved in human physiology. They are alpha linolenic acid, which is also known as ALA. It is found in plant oils. The second one is eicosapentaenoic acid. Remember, pentaenoic acid, that is, it is also known as EPA. And the third one is docosahexaenoic acid. Do means it is having, do plus cos means it is having 12 number of carbon atoms, and enoic means it has a double bond in it, which is also abbreviated as DHA, and both EPA and DHA are commonly found in marine oils. So let us discuss these acids, that is omega-3, one by one. The first example is that of alpha linolenic acid, which is also known as ALA. It is present in walnuts, flax seeds, canola oil, red meat and dairy products. So now when we say that this is a 18,3 N-3, what do we mean here? We mean that when we start, this molecule has 18 carbons in it, and when we start the numbering from the methyl side, it is having the first double bond is at the third position. So this is it, and then it has 3 double bonds in it. So 18 carbons, 3 double bonds, and N-3 or omega-3 indicates that these are omega-3 fatty acids, and this is an essential fatty acid. And why is this essential fatty acid? Why is this a very important fatty acid? Essential or non-essential, I'll be discussing later on. What do we mean by that? It is necessary for normal human growth and development. It decreases the risk of heart disease by helping to maintain normal heart rhythm and pumping. And it also reduces blood clots. Therefore, this acid is very important. Now, the next omega-3 acid is eicosapentaenoic acid, that is EPA. As I've said, this is found in fish oil, and as you can see from C20 N-3 or omega-3, what we mean here is that this acid is having 20 carbon atoms in it. It is having 5 double bonds, 1, 2, 3, 4 and 5, and it is a N-3 or omega-3, that is the first double bond is at third position when we start the numbering from the omega end. The third omega-3 acid, which is important, is docosahexaenoic acid, which is also known as DHA. This is found in, again, fatty fish and marine algae, and again this is also a omega-3 acid, and as you can see when we are doing the numbering from here, we will start numbering from 1, 2 and 3. You have to ignore this numbering which is given at the bottom, because this numbering is when we are numbering it from the carboxylic end. But when we are talking of omega acids, then in that case we have to, when we are naming them as omega, we have to start the numbering from the omega end or the methyl end, and the first double bond is at the third carbon. So this is what the omega-3 signifies here. And then this acid has 22 carbon atoms in it, and it has how many double bonds? 1, 2, 3, 4, 5 and 6 double bonds. So 22 colon 6. 6 indicates it has 6 double bonds, and this indicates, omega-3 indicates that it is a omega-3 fatty acid, and the double bond, the first double bond from the methyl's end or the omega end is at the third carbon. Now, DHA is a vital component of skin and retina. It is important for brain development, and if there is decrease in DHA in later phases of life, it leads to Alzheimer's disease, because please remember, this fatty acid is very important for brain health. And when we talk of ALA, what we find is that this is the most common omega-3 fatty acid, and it gets converted into EPA and DHA. However, in humans, this process is very slow. At least now we know that 8 other omega-3 fatty acids have been discovered which have some biological role, but they are non-essential fatty acids. So till now I have discussed with you the classification of unsaturated acids, and I have told you that unsaturated acids can be of two types. That is, they can either be monounsaturated fatty acids, which are MUFA or monoenoic acid, and then they can be PUFA, that is polyunsaturated fatty acids. And when I have discussed in detail with you the MUFA, and I have started with the classification of PUFA, where we have discussed omega-3, the general concept of a fatty acid, and I have also discussed with you the omega-3 acids and their importance. For this lecture, I had taken the reference of Bruce, McMurray, Finar, Morrison and Boyd, and Solomon. Now in my next lecture, I shall be continuing with the classification of PUFA, that is polyunsaturated fatty acids, where we shall be discussing omega-6 fatty acids. Then we'll go on to essential and non-essential essential fatty acids, followed by nomenclature of fatty acids, where I will clarify the difference between the omega end, which is the methyl end, and the carboxylic end. Thank you.